So we tried it ourselves, and I'm going to tell you a little bit more now about all that junk you at the end, and I'll talk more about it when we talk about structural equation models and confirmatory factor analysis. So we fit indices, and if you go and look at your data set, it was not really great. So, but the one I had was slightly better. So RMSE is the root mean square in approximation error of I don't know. I don't know it by heart. Sorry. It will write it here in full. So it's RMSE. It's not written it in full. The root mean square error of approximation. That's what it's called. Sorry. So that's the RMSEA, which we have here for a 3-factor solution. I can also get one for a 5-factor solution. So those things are the things that are printed at the end. So those are the fit indices. And ideally you want it to be close to 0.06 or 0.05 for the RMSEA. So we're slightly above that, so it's not great. So some people say 0.06, other people say below 0.08 is acceptable. Again, it's sort of a gliding scale, and statisticians fight and argue over this and say, oh, it should be 0.08 or 0.06. Or, and you should note that it's sample size dependent, the RMSEA. So larger samples will make for smaller RMSEAs most of the time. And the other one is the TLI, is the Tucker-Lewis index, and you want that to be close to 1 would be perfect, and so it would be above 0.9 or above 0.95. And so in our case, we're at 0.8 for 9, so that's where it's based. So this is the Tucker-Lewis index of factoring reliability. There's some other measures like BIC and some other measures which we'll discuss more when we get to RMSEA. So if you go back to your data, the one you did, you will find that it didn't do very well. Most likely, it did quite poorly compared to this. But that's the nature again of trying to find your own factors. So don't be too shocked if it's quite low. So for things like validated personality, we should be getting close to what we expect, but not always. But for now, you should know RMSEA and Tucker-Lewis index. RMSEA close to 0.05, 0.06, or 0.08. Tucker-Lewis index larger than 0.9, 0.95 is great. So if we go back to the model, the 5-factor model does better than 3-factor model, but you should be aware that it's because we sort of know it's a 5-factor model, and it's we did exploratory rather than confirmatory factor analysis. And so what you write in your write-up, for example, would be the 5-factor model could be considered a close fit in RMSEA because it's 0.071, so that's below the 0.08. So that's fairly close, but it was not in terms of TLI or the Tucker-Lewis index because it falls short of that 0.9 criterion by a bit. Yeah. So that's a sample write-up you would do for your factor analysis. Now, again, we have choice paralysis. We have so many options to pick from. So you saw that I picked MinRes factor analysis. You could pick many other options there. You could principal actor factor analysis, access factor analysis. You could pick weighted least squares. You could pick generalized least squares. You could pick maximum likelihood. You should know that MinRes and principal access factoring are the ones which are mostly used. Most of the time, you'll get similar results. Sometimes you'll get very different results. But this is how the factors are extracted from the data. And it's basically how we find this linear combination of factors. And as always, mathematicians have come up with different solutions to finding different solutions to the same problem. So you should know MinRes and principal access factors. They're the ones that are mostly used. Occasionally you'll see other variants. Most of the time it won't matter too much. As an example, here I've changed it to principal access factoring. And so you can see FM is now PA, so that's principal access factoring rather than MinRes, what we had before. And if we then do the same type of parallel analysis, we again get close to five factors. So in many cases, it doesn't really seem to matter that much which one of those you pick because they're all different ways of calculating and getting to the same solution. Now, we can then try to extract the data. Again, sorry, this is overflown, but you can get from the raw code, which I also upload, you can get what is at the end of the brackets. So this will just continue. So V1 is factor 1, V2 is factor 3. So it will go V4 is factor 4. So we'll just continue to those ones. And this one just has type is HTML at the end. So it's occasionally it overflows, even though I tell it stays between the brackets, it will overflow. So what we did here is we took Stargazer, we took the factor loadings, we made it first into a matrix and then into a data frame, and then we're gonna we rename those factor loadings. So it says factor 1, factor 2, factor 3, factor 4, factor 5. You could relabel it based on openness, agreeableness, all those kind of things. So you would more sensibly relabel this as being the ones that we had before. You remember, like extroversion, introversion, openness. But this is just a basic example of how to get your table. And what we then do is we use Stargazer, and now the only thing is we say summary is false, because otherwise, as you remember when I did it first at the beginning of this lecture, it will have printed the summary for these data frames. So it said mean, standard deviation, minimum, maximum, percentiles, and now we don't want that. We just wanted to print the entire data frame of that, which now has the factor loadings in it. And so, because this overflows, I can also show you what it looks like. It should look like this. Oh, I opened it twice. So you can then further change that. So you could further change that so it has better labels, and you could make sure that this has, rather than this number, it has the question item, so talkative, all these other things, by binding that to your data frame. But I've not done that. So so basically, what it does here via Stargazer is just printing that data frame as an HTML file. And what you can then do is, once you've done that, rather than having to copy, paste, and edit in Excel, you could then paste that directly into your report, and it has all the factor loadings. But that's quite a lot. So sometimes people would only report really strong factor loadings because it's a very busy table to go and look for the really high or low scores. So sometimes people only print factor loadings over 0.6 or something. So we can also try to make a figure for it. It's a very messy figure, but this basically has the labels. So it basically uses GPA rotation, and then for each one it will sort of show the rotation of these factors. But it's such a I think it's quite a mess because it's trying to print all these 32 items to the data frame. So, but you should know this exists. So this is a way, because then you should see the clustering of these dimensions. And you might be able to make out some things. For example, you could see quiet, distance, all these things seem to be grouping together. And so again, it should give you the 5 clusters. But what usually happens is that we can just look at the first 2 factors rather than doing all 5, because that will be more sensible. And what I've done here is I've removed any loading below 0.5, so that we are only zooming into those factors. So that basically means we have two dimensions, and it is, as I said, in opposite space. So you have outgoing, talkative, and here you have distant, shy, quiet, and withdrawn. So not axis. Yeah. On the opposite, you have disorganized, lazy, persevering, hardworking, disciplined. Yeah. And the thing clustering in the middle are things which don't discriminate in those 2 dimensions, but they might still be loading 0.5 in one or the other dimension. Yeah. So that's how you read this type of plot. So it usually doesn't make sense to try to plot a whole lot of factors, so all that information is in here somewhere as well. Yeah. But usually it's best to zoom in on a couple of factors and then show on one end of this axis we really see this factor really differentiates between, so this factor really differentiates between talkative, introversion, extroversion, and this one really differentiates between being conscientious and not being conscientious. Yeah? So that's how you read those things. So rather than, I would highly recommend you do it this way. So what I did here is I used factor.plot or 5-factor model, I said choose just the first 2 columns, cut it at 0.5 for loadings, and use as labels the column names from the labels. Yeah. And in your case, you would have to relabel your columns because otherwise it would be item 13, item 15. You would have to figure out a way around it. Okay, you can also use ggplot2, and there's some ways of doing that. You can see some examples in here. You can make a really nice type of bar graph if you wanted to do it like that way. So there's other ways of visualizing these type of factors. You can also plot the correlations as we've done. We've done that via these dots, but you can also put the numbers to it. And then this one has all the loading strength for all the items as a sort of stacked bar chart. So again, I've shown you a basic way to do it, but you can always do more advanced and fancy plots. And you should also know that there's some extensions to this. And again, I can't go into detail, but there's multiple group factor analysis. So you can have a group component to compare different groups. But you also might just want to have Cronbach's alpha sometimes. You will have calculated that. There's lots of debates. Usually, I think it's not good to settle on Cronbach's alpha. I use it as well because we get asked for it by referees. But if you just want a Cronbach's alpha, you can do it via the psych package as well, and it's very easy to do. But people have argued you shouldn't rely too much. So you can have a very high Cronbach's alpha, but it could still be a very poor factor solution, a very poor factor one. So more and more, the field is moving in towards using factor analysis and better measurement techniques rather than just using Cronbach's alpha. And you can click on that link to find out how to do it and why you shouldn't rely on it. So I think that's it for today. So I have an exercise for you, and there's the big BFI data from the psych package, and it has personality measures from over 2,800 people doing the Big 5 by the IP pool. That's the International Personality Inventory pool. And you'll have to subset the variables for your factor analysis. So you have a large database. I would like you to do Bartle's test and KMO test, similar as you've done. And then I would like to do an export factor analysis using the min-res as a method, and then do parallel analysis, discuss discrete plots, differentiating a simple structure, and the velocity map test. And then you can extract a 5-factor model using the Varimax rotation. And I would like to export the factor loadings of these 5 factors, discuss the fit indices, and make a plot of those factors. So that's to keep you entertained. And again, lots of things I have to condense here, and I know you would like to find lots of more things, but there's lots of things for you to read about in case I haven't covered it in full. And so you can have some clicks here and some books also to find out more. Okay, next week, if I'm not mistaken, we're going to continue with factor analysis, but we're going to do confirmatory factor analysis in structural equation models. That's it.